All right, welcome to this edition of College Trig, 5.33 Properties of Trig Functions, mainly the Pythagorean Identity. So the Pythagorean Identity comes directly from the equation that we have of a circle. Remember from College Trig that we have the equation of the circle being x squared plus y squared equals your radius squared. Well, if we're dealing with the unit circle, notice the unit circle, our radius is equal to 1. Our x's is equal to cosine of theta, and y is equal to sine of theta. If we plug those into our equation of our circle, we see that we get x squared is cosine squared theta plus sine squared theta is equal to 1 squared here. Rearranging these, we can see we get the Pythagorean identity from here. The next slide, we can see if we want to use that Pythagorean identity, we can divide everything by cosine squared theta, divide by cosine squared theta. And what are we going to get? Sine squared theta over cosine squared theta. Well, that's tangent squared theta. Cosine squared over cosine squared is 1. And 1 over cosine squared is the reciprocal secant squared theta. So that's how you can see we can get our second Pythagorean theorem identity. And for our next one, we also get, for this one, we just have to divide out by sine squared theta on both sides. That simplifies to 1. Cosine squared over sine squared is actually cotangent squared, which is 1 over sine squared theta is cosecant squared theta. So you can see how we get our third Pythagorean identity. Well, we'll be seeing a lot more of those Pythagorean identities and see how those can be useful. Next, I want to talk about complementary angles and the relationships here. So remember, complementary angles are two angles that their sum are 90 degrees. And what are going to be the relationship between the trig functions and complementary angles? So what I want to do here is start looking at an idea here. So if I have an angle theta 1, and we can see that theta 1 and theta 2 are complementary angles. If I call theta 1 and I draw a triangle here, and I label this side A and this side B, I can see that for this one, for theta 1, the cosine of theta 1 is equal to my x, which is B, and my sine of theta 1 is equal to A, assuming we're on the unit circle. So if I move my theta 1 away, and I take my theta 2 and kind of turn it around so that it's based upon my x-axis, notice that when I take my red triangle here, kind of flip it around, and that you can see here that the value where theta 2 ends is the same value but flipped around. So for my triangle here, which was the same as before, for my theta 2, I can see that my cosine of theta 2 is equal to cosine is now, which was my b before, is now my a, and my sine of theta 2 is equal to b, my y. So a specific example can be seen on our unit circle. Notice on our unit circle, the cosine of 30 degrees is square root of 3 over 2. Well, its complementary angle, 60 degrees, those add up to 90 degrees. We can see that its cosine is the same as the sine of its complementary angle. And then I can also see that true for the sine of an angle and its cosine of a complement are going to be the same. Let's see an example how this can be useful. So I'm given this equation here, and I want to solve it without using my calculator and get an exact value. So first thing what I'm going to do is I'm going to draw a triangle with a hypotenuse of 1. Okay, labeling my angles. So let's say this is 10 degrees. This is 80 degrees. Right angle, hypotenuse of 1. And again, I'm just going to label my sides with, let's go ahead and label them x and y. So to refer back to the cosine. Well, cosine of 10 degrees, so cosine is x, sine is y. Okay, and I'm going to use this triangle to just substitute in what I know. So from this, I'm going to see the cosine of 10 degrees is going to be x. Now the sine of 80 degrees, so now I'm thinking about this angle as my reference and not 10, so I'm not necessarily thinking of x and y, but I'm going to refer to my opposite over adjacent. So sine is opposite over hypotenuse. Well, that's x over 1. So that 2 is x, because we're talking about the same side, just different reference angles. So then we can add that. And so now if we think of sine of y, or sine of 10 degrees, that is going to be our y. And the cosine, the adjacent side of 80 degrees, is also y. Well, if I do x times x, I get x squared plus y squared. And what does that equal to? Remember, I'm all basing this off the circle, and I know that if I have a unit circle, I have x squared plus y squared equals 1 for my Pythagorean theorem. So if I have x squared plus y squared, I can see that this is all equal to 1, and this is 1. And you can verify it using a calculator. That's it for tonight in the videos. I'll see you in class tomorrow, and don't forget we have our quiz tomorrow.